Now we're going to study integration by substitution. In this function, we have an integrand which looks like a multiplication of two functions. However, in this function, one of them is a derivative of the other. So let's say this is our function, the other one is a derivative of the other function. So what we can use here is the method known as u-substitution, okay, derivative of the other functions. Sorry, I forgot to write that. So we can use substitution here. Okay, I will explain this method in the next slide. Let's try to work on example A. It looks like we have an integrand which is a multiplication of two factors. But what is noticeable here is that this one, the other function or one of the functions, is a derivative of the other function. So this is derivative of that function, that inner function, 3x squared plus 7x. So what we can do is to represent the function where derivative is taken from as u, so or the one with a higher degree. So 3x squared plus 7x. If we get the derivative of this u, we have 6x plus 7, which is actually this part. So if we're going to represent this, it's the same as the integral of u raised to 5. By the way, this is du in terms of x. So u raised to 5 times this function, 6x plus 7. And then what about dx? So if we're going to represent dx here, taking from here, then our dx is equal to du over 6x plus 7. So let's try to substitute that here. Okay, this is this one, and this is this. So we have our dx is du over 6x plus 7. Okay, so we can already cancel this out. So we are left with this integral of u raised to 5 du, which is basically the same as integral of x raised to 5 dx. So it's in that format. So how do we integrate a power function? So it's going to be u raised to 6 over 6, then plus c. Why plus c? Because we are dealing with indefinite integral. But then you can looking at the given, there is no u there. Instead, what we have is a function with variable x. So we are going to substitute back the u here, which is this. So this is the same as our u is 3x squared plus 7x raised to 6 over 6, then plus c. That's the end of it. You may replay this video so that you get used to the methods of u substitution. Let's do letter B now. It looks like we have these two functions, and which one of them is the derivative? So the one with the lower degree, that will be the derivative of the function here. Let's call the function, the inner function, as u. Okay, let me write here. I think I have more space here. So let our u be equal to x raised to 5 plus 3. So the derivative of u is, what is the derivative of u? It's 5x raised to 4 in terms of x, right? Or we say that the derivative of u in terms of x is equal to 5x raised to 4. Another way of saying that is that the derivative of u is 5x raised to 4 dx. So they're basically the same. Let me erase this part. Okay, you can contemplate on that. So the next thing that we are going to do is to rewrite this. So this could be written as the integral of x raised to 4 cosine u dx. But what is our dx? Here, our dx from here, from this point, is the same as du over 5x raised to 4. So let's replace that with this. X raised to 4 cosine u. We are substituting u to the function that is to be derived. And dx is du over 5x raised to 4. Then we can use cancellation here. So we are left with the integral of cosine u du over 5, and that could be written as, we can take out the constant, which is 1/5. So we're getting the integral of cosine u du. So it's similar to getting the integral of cosine x dx. And what's the integral of, well, let's evaluate. So it's 1/5. The integral of this function is what? Sine u. Do not forget plus c. So the integral of the whole thing is sine u plus, don't forget, plus c, because we are dealing with indefinite integration. But then again, there is no u in the given problem, so we have to return u back to itself. So let's do that. It's going to be 1/5 sine, what is our u? This is our u. Sine x raised to 5 plus 3, okay, close parenthesis, plus c. Okay, so this is our final answer. Okay, let's do letter C. Which do you think shall be represented by U? You can pause and then try to answer that. Okay, let's continue. So we can write this as our U. So in that sense, this is the same as the integral of 2x e raised to u dx. Then we're going to rewrite this. Okay. So again, our u is 3x squared. So derivative of u in terms of x. so it's written this way, is how much? 6x, right? 6x. So how do we write our dx in terms of this? So because why do we need the dx? Because it's written here. So our dx is equal to du over 6x. Now let's try to rewrite this. It's going to be 2x e raised to u, and our dx is this, du over 6x. Now we can apply cancellation here before we integrate. So 2x and 6x, we are left with how much? 1/3, right? 1/3 e u du. And this could be written as 1/3 integral of e u du. Okay, pause for a while and try to recall the formula for integrating eu. So our answer is, so the integral of this is what? E u plus c. Again, let's return it. Okay, because we don't have u in the given problem, instead we have 3x squared. So this is the same as 1/3 e raised to 3x squared plus c. So this is our answer. Okay, let's do the last problem. Instead of uh, multiplication, it looks like we are dividing here two functions. So which do you think is to be represented by you? Is this function or this function? The numerator or the denominator? You can pause and then think of the answer. Okay, so if you remember what I said a while ago in the first example, the one to be represented by u is the one with the higher degree. In this case, it's the denominator because the degree is 4. Okay, so let's call this our u. Let's call our u 2x raised to 4 minus 5x cubed. So in essence, this function could be written as the integral of 8x cubed minus 15x squared over u times dx. Okay, so let's find our du in terms of dx so we can represent dx later on. So the derivative of our u is 8x to the third power minus 15x squared. Therefore, we can now represent our dx here as du over 8x cubed minus 15x squared. Okay, it's a matter of manipulating your equation. So let's rewrite this once more. It's the integral of 8x cubed minus 15x squared. This is actually the same as 1 over u. And then our dx is, okay, let's use this class, is our dx. So we represent dx by du over 8x cubed 8x cubed minus 15x squared. So here We can cancel these two out, so we are left with integral of 1 over u du. So again, pause for a while and then try to remember the rule that gives you the integral of 1 over x dx. It's basically the same rule. You already know that? Okay, so our answer is ln u, okay, plus c. And then again, we return the original given value. So we have ln of what? Of the u, which is our u, the original, this one, okay? 2x to the fourth power minus 5x cubed. And then don't forget again, because this is indefinite integration, plus c. And please try also to remember how we are getting the value of c. It's already discussed previously. Okay, so the final answer for letter D is this one. Okay, so if you have a problem understanding, maybe the first thing you can do is to keep on repeating the explanation from letter A to letter D. I would like you to work on the exercises on 13G. The answers in these exercises can also be found at the back of your book. So keep on working. See you again.